Hello and welcome to another event in our Tech Talk series. Today's presentation will cover Introduction to the Force.com database. As you may know, Salesforce.com is a publicly traded company, and therefore we do need to share the safe harbor statement with you to let you know that any forward-looking statements are just that, forward-looking statements. If you'd like to learn more about the safe harbor statement, you can find it on our website under the Investor Relations section. So with that, I'd like to introduce Andrew Albert.
Thanks, Sheridan, and welcome to today's Tech Talk session, an introduction to the Force.com database. My name is Andrew Albert, a technical evangelist here at Salesforce.com, and I work with ISVs and developers that are looking to build applications on the Force.com platform. I'm joined today by my colleague, John Mountjoy, who is a developer Force community manager and will be jointly presenting on today's Tech Talk. Today we're going to cover a few items, starting with a Force.com database overview where we will talk through where the Force.com database layer resides in the context of an entire Force.com environment. Next, we'll go through key Force.com database terminology and how it is slightly different from traditional database terms. Then we'll review the key Force.com database fundamentals to articulate its components, features, and capabilities. We'll follow that up with a demo to show in real time those same concepts in the context of an actual Force.com application.
Thanks, Andrew. Before Andrew starts us off, I wanted to ask everybody in the call, what do you need to build a web application? And you typically need things like authentication, authenticate users. You need a database. You need a user interface, perhaps a different one for different roles, security search, business logic, and auditing, and maybe some more. And what we'll show you in this presentation is that the Force.com database gives you a lot more additional services around what would traditionally be called just a database. And if you need to build a database-centric business web application, much of the hard work is already done for you. So all of this is really driven by something which we call metadata. That's data about the database, for example. And you'll be seeing a bit of the metadata throughout today's talk. It's what lets us add, for example, a validation rule and a second later have it active and live. But these things also drive something else, productivity. And imagine a system that provides simple ways to build in data validation or immediate prototyping, or that lets you easily integrate with coding layers, for example, or run reports. And we hope to show you some of this today, but we want you to keep us honest. So I really would like you to think about productivity as we give this presentation and evaluate for yourself how easy or difficult this would be to implement.
Let's start by looking at a diagram of how a Force.com environment is architected. As with any enterprise application, the core underlying layer is the data layer, or in this case, the Force.com database. Force.com provides the ability to define your own custom objects that make up your relational database. But the Force.com database provides much more than just custom relational database in the cloud. Since the database is seamlessly embedded into the Force.com platform, several key application services are automatically enabled for your custom data model. For example, the platform provides a rich set of functionality to implement data security, such as assigning different CRUD permissions to different users and going as granular as field-level security. Next is the logic layer where the majority of your business logic is implemented. This includes validation rules, workflow rules, and custom business logic written in Apex code. In the demo, we'll show the database seamlessly ties into this logic layer. This is followed by the presentation layer, and Force.com provides an out-of-the-box page layout editor along with Visual Force, which is the Force.com markup language to give the developer full pixel-level control. Finally, Force.com provides a robust set of web service APIs that allows your data to be exposed through an integration layer. This gives you a quick overview of a Force.com environment and where the database resides. Before we go any further, I want to define some common terms John and I will use throughout this webinar. Usually a database consists of tables, but in Force.com we use the term objects. A Force.com object provides many of the key features of a standard database table, but it also provides many more platform services. For example, it seamlessly integrates into our application and presentation layers. Secondly, the concept of a column is termed field in Force.com. Similar to objects, fields provides a richer set of application services as compared to a standard column, so we do not want to confuse the two terms. When it comes to a relational model, Force.com uses the term relationships instead of foreign keys. Lastly, instead of talking about an individual entry into a table as a row, we will refer to a database row as a record. I'll now pass the conversation over to John to walk us through more of the Force.com database fundamentals.
Cheers, Andrew. So we have about 4 slides just to give you an idea of what goes on behind the scenes. And then Andrew's going to give us a demonstration which really makes it all a lot more concrete. And so we'll start with this notion of objects and fields that Andrew just spoke about. So in a traditional database, the key is really the data model or the schema. And our database has this concept of objects to define your tables that store this persistent data. And the objects really represent the table definition, but also a lot more. So for example, you also get a custom user interface automatically generated. And we'll show you this in the demonstration. You can also use the objects that you create in reports, for example, to view and visualize the data. So a default view of the data is already available just by creating the model. And that's a really powerful little feature. So you must think of this object as a rich sort of metadata that really describes the shape of the records that you want to store and some hints on how to view the data, validate the data, access the data, and so on. So with respect to the object definition, Force.com supports about 20 different field types. Some of them are quite standard, like text and date, but we also have some pretty powerful ones like formula or currency. So, for example, the formula data type lets you configure spreadsheet-like formulas that are evaluated in real time. And the currency data type lets you store number values that lets the Force.com multi-currency platform feature change the calculations based on conversion rates, for example. And additionally, data stored in the Force.com database is automatically available to a web services API, although we won't show that today. So now that we have these objects that store data, we need to think about relationships between objects. And you're probably used to fighting with foreign keys. And the Force.com database differs again from standard relational databases in how this foreign key notion is implemented. So instead of having to deal with keys and foreign keys and primary keys and defining relationships in terms of these keys, the database does this for you, and instead you deal with a much higher level notion of a relationship. So a relationship is a field type, and it defines how two objects are related. And we can use this to generate things like links in the user interface as well. And we have two types of relationship fields on Force.com. We have a lookup relationship, and this allows you to create a relationship between one object and another, and it allows you to navigate from one to another, for example, both visually and programmatically. And then we also have something called a master detail relationship, and this is a special type of relationship that makes this bond a lot stronger. So here we typically have a detail object and a master object. And what we have then is things like cascading deletes. So if you delete the master object, all of the records in the detail object are also deleted. It also gives you some interesting features like a master object can have a special field type called roll-up summary fields. And these roll-up summary fields really store aggregated data from all the child records in the relationship. So for example, you can use this field to count the number of child records or some values in a field in the child record, and so on. So now I can hear all the developers among you screaming, well, what about identity? And of course, identity is really important. And Force.com database handles it for you. So if you've dabbled in the platform, you might have seen these strange URLs where we have this 15-character case-sensitive form. And that's really the identifier for that record. And you can actually just create a URL like that to access any record. And of course, you'll be able to view that record if there is a detail screen available and if you have the appropriate permissions. And when you do view the record, the platform will automatically retrieve the record and the associated metadata and display that record using the automatically generated user interface. And of course, it does all this in real time and really fast. There's also a couple of other read-only system fields that we maintain. So we've spoken about the ID field, but we also have things like a created date and a created by, who created the record and who last modified the record and so on. And these are automatically handled by the Force.com database. And as you can imagine, these are quite useful when you're building auditing, for example, into your applications. And auditing brings up another powerful feature, which is security and sharing. And before I look at the demo, I do want to say that we offer quite a few different ways for you to control access to the data. So there's one thing putting data into your database. There's another, controlling who sees that data. So for example, we have object level security, which for example means only managers have access to a bonus object, for example, and all its data. We also have things like record level security. So for example, if I created a record, then only my managers should be able to see that record. And you can define what that actually only my managers actually is. And then we also have a very granular security, field level security. So there you can control, that only some users or certain profiles can view certain fields, or for other profiles that field is read-only or read-write. You can control all those things quite finely. And those are all controlled by creating a profile. So you create this security profile, which contains the create, read, update, delete, or CRUD as we call them, permissions. And then you can assign your users to these different profiles. And finally, Force.com also has a really nifty feature for sharing records. So if I have access to a record, I can either programmatically or using the interface determine who I share that record with. So all combined, we get quite a powerful suite of security and sharing around data security. So now we're going to switch gears and hopefully put a lot of this, make a lot of what we're talking about a lot more concrete. So Andrew, over to you.
Thanks, John. Before I move into my browser, I did want to highlight the simple application we are going to build live in this demo. This slide just represents the ER diagram that we're going to build out with Force.com custom objects, where it's going to be an expense management system where we're storing the expense report as well as its related line items, all of the different receipts such as mileage, rental cars, lodging, things of that nature. So we're going to be creating a one-to-many relationship between these two objects. So I'm going to hop over to my developer edition in my browser. And what I've done previously is created a custom app in my Force.com apps dropdown, and I've created an app called Expense Management. But now I want to build out the first custom object. So as a developer, I go under Setup, Expand Out Creates, and go into Objects. And this is where I can create my first object, which I give it a label, which is what shows up in the user interface. Expense report's an object name. And then it asks me for a record name. This is a required field on all objects. It can be a text or auto number, and we can let the system generate the name field. For the expense report, I want the user to enter the name of the report. Give it a title. And this is where the Force.com database is starting to be tied right into our application and platform services. Under optional features, I can just with a checkbox enable the data stored in this object for reporting. I can also allow tasks and events to be tracked against this. So maybe as throughout the approval process, I want to track some activities and assign tasks to people. And auditing is just a checkbox to enable auditing so I can track who creates the record, what fields have been changed, and we can have some compliance tracked through the field history. I can also add notes and attachments. Maybe I want to upload the receipts. And I'm going to launch a new tab wizard so I can create a view in the user interface to automatically see the data stored in this object. So now it's going to walk me through the custom object tab wizard. I just need to select an icon here. I'll select the form. Hit next to walk through this wizard. I want all of my profiles, all my groups of users to be able to see this tab. But this tab, this expense report tab, is really only relevant to this one application in my org. Again, these are I have sales, call center, ideas, but again, we have a custom app, expense management. I only want this tab and this object accessible through that application. So now my custom object and my tab is defined. As we mentioned earlier, there's some identity and system fields that are automatically generated by our system, such as the created by and last modified, who created the record, who's updated the record last. And under custom fields, this is where we're going to build some of our extra fields or columns. Step one is to choose your field type. There's about 20 in here. So the first example will be a date field. And I just need to give it a name. I'm going to give it a date of it. Give it a little help text. I want this to be a required field, so I just hit the checkbox. And most likely, to help with user experience, I can use this formula builder to default, when I create a new expense report in the UI, that I want it to default to today. Most likely, the value I want in this field is today. So I'm going to use this syntax to create a default value to help the user experience enter in that field value. So I complete the new field wizard. I hit save and new because I want to create a second field. This will be a type pick list. It's equivalent to a drop-down. Again, give it a field label. This will be status. So what is the status of the expense report? It could be in draft, submitted, approved, or paid. I want the default value to be the first one. So when I start creating it, I want it to be default to draft status. And I add it to the page layout, which we'll get to shortly, and I can hit save and new. And for each expense report, I'd like to have a description. I want the user to enter in a little bit more text about the reason and why they went on this expense or on this trip, business trip. So I'm going to select text area long. We'll give it a description. It could be up to 32,000 characters. I'll just say this makes more sense to be 2,000. It has character return, so I expose the number of visible lines. And I walk through the wizard, and I hit save. So I simply created 3 custom fields to track some of the header information about this expense report, just to show you some of the key different data types we support on a custom object. So now I want to go create that second object, which would be the line items. This is going to store all of the individual line items for a given report. So I start off with custom object again, call it line item. And it's going to walk me through the very similar wizard that we saw for the previous object, but this time it's at the name field. I want to use an auto number. The name concept doesn't really make a lot of sense for a line item, and so I'm going to let the system automatically specify an auto-generated number. So anytime a record's created, the system will generate a name field and populate it since it's a required field. Again, I want this to be reportable, and for line items, I don't need to allow activities, and I do want to track field history. And I'm not going to add notes and attachments or a custom tab. I don't have to select those. So I'm just going to hit save. And again, custom object's been defined. Those identity and system fields are created for you. And now we're going to want to add some new custom fields, again, for the line item. Let's start with a pick list. For each line item, we'll want to know the type of line item it is. Is it for lodging? Is it for mileage, airfare, rental car, or other? Simple list of pretty common expense report type line item types, and we'll hit save. But for each receipt you have, you also want to enter the amount. And we'll want to use the currency type. As John mentioned earlier, this is going to be a number field that is tied to our multi-currency functionality, so different currency types can be converted by defining a data type field as a currency field. And this will just be for the user to enter the amount for each line item. And we give it some precision, 2 decimal points, and we want that to be required. Make sure no user can enter in a line item without an amount. So at this point, we have an expense report object, and we have a line item object. But there's no relationship. There's no foreign key tying them together or creating that one-to-many relationship between the two. So the next field I'm going to create is that relationship. And we're going to use a master detail. This is going to require, for any line item, you must have an expense report tied to it. It's really defining that parent-child relationship. And what the wizard's going to walk you through is which object do you want to make the parent? Which one do you want this related to? And in here, I have my custom object I just created previously, expense report. Complete the wizard. And this is not only creating the foreign key in the data model, it's also enabling the user interface to create that one-to-many relationship. So it's adding a related list onto the page layout, which we'll show in a second, that for each expense report, I can go and create multiple line items in the user interface. So it's taking it from the data layer all the way through the presentation layer. And with hitting save, I've now defined that relationship to the expense report object. One last field type I want to show is the concept of a roll-up summary field. Since we have multiple line items or multiple receipts, and each receipt is going to have an amount, I want the system to do that calculation and roll up for each expense report. I don't want the user to have to not only enter every line item, but also do the calculation. So on the expense report, on that parent object, there's a data type for a field called roll-up summary. So I'll select that, and I want to say total. Give it a name, and now it's going to walk me through a very simple wizard to define how I want to roll it up. So the summarized object is going to be that related object line items. The system knew that there was a relationship, so it gave me that object in the dropdown. I want to sum the amount field. So it's going to roll up all of the related line items into my total field that I'm defining here. So I'll just save. And with that, we created a roll-up summary field that the system will automatically generate. While we're here, I want to show how easy it is to enable audit history for these custom objects. While I'm looking at the custom object definition, there is a set history tracking button. And in here, with simple checkboxes, I can enable what fields do I want to track the changes of. So as expense reports are entered, the status is changed, I can track who and when that happened and from what value, the old and new values. So I just enabled tracking field history through that process. So we talked about how the Force.com database is automatically tied to a default page layout. And that's what shows up here in your custom object definition. So I'm going to edit the page layout. I can drag and drop the fields. Notice that I have these related lists down below. I automatically have that relationship of line items tied to an expense report. I can even drag related fields of the line items onto the expense report detail page, and I'll show you that. So I just move some fields around. I hit save, and in real time, those two objects are created, the relationship's created. We edited the page layout, and now I can automatically go in and I have a default page layout. So I want to create my first expense report to show some of the other application and platform features that are automatically enabled by defining your data model on Force.com. So I had a sales demo in Phoenix last week. Required field is date. It defaulted to today. That was off that formula we used, but really I got a little lazy and the trip was actually last week. I went to visit a prospect, and the status is draft. So now I created my first record in this user interface. Up at the top, you have this A05. That is the 15-character record ID. That is a unique record ID for this expense report, the sales demo expense report. And in this user interface, I can also create related line items. So for my line items, I had airfare. It cost me $312.45 to fly there. I can hit Save and New, and my lodging costs another $410.12. And I can go back and look at that relationship at my expense report and my multiple line items down below. And to show the power of that roll-up summary field, I never did the calculation, but I let the system roll up the lodging and the airfare to $722. You also can see the created by. So I was logged in. I created this at 10:29. If I go in and edit something, the last modified by changes to that timestamp to show you some of the system fields that help track changes. Additionally, in the search box, in real time, I know I had an expense report to Phoenix. So in my search window, I type in Phoenix, and that record I just created in real time is automatically indexed and searchable through our platform. Another service automatically enabled for you is reporting. So just to real quickly show you how in real time you can build a report off the data stored in your custom objects, I can quickly build a report for expense reports with line items, walk through a point-and-click wizard. You're not going to write your SQL statements. You don't have to set up an analytics server. I can show, I'm just selecting some fields to show, And granted, I have very simple data stored. It just shows how powerful and how quickly you can build your application and go from the building a data model to entering the data to building reports on top of it.
That's awesome, Andrew. So I actually timed Andrew, and I think he took about 12 minutes to do all that. And what he did essentially was just define a database model. But of course, as a result of that, what he got was a lot more. He got a complete web application with a user interface for entering records, for validation, for searching, reporting, and a lot more. And so I hope you guys are still thinking about the productivity in the back of your head. But of course, you can do a lot more around the database than just this. In particular, for example, we have a web services API, and the web services API lets you access the data. And you can do this by writing your own clients, for example, to pull or push data to your application. But you can also use a metadata API. So we spoke about this metadata. Well, it also has a web services API, which means that you can, for example, write applications or that and download your application metadata. And we actually have a client built around the metadata API, and one of them is the Force.com ID, which Andrew's going to show right now.
Great. So I switched over to my installation of Eclipse running on my laptop with the Force.com IDE installed into my Eclipse environment. And I have a Force.com project that is tied to that same developer edition org or environment I showed through the user interface. But this is more of a developer view of how you can use the IDE to help build your applications and your data model. So I'm just going to hit a refresh from server, which is going to use our metadata API, go up to that, log into that server, and bring down that metadata. And under the source folder, you'll see some of the different types of components we have. But I wanted to show under objects, I can open up the expense report metadata. That is the configuration of that expense report object. And for example, here's that status field with all those pick list values, draft, submitted, approved. But it's just not a read-only view. I can create a new pick list value in here. Let's say the expense report was rejected. So I'm adding a new pick list value in the IDE. When I hit save, it's using web services and pushes that change up to our service. And if I hop back over to show you how that truly worked, when I go into my status dropdown, rejected is now set up as an additional pick list value. That is how the IDE is integrating and tying into this same environment I was demoing earlier. Now let's show our SOCL language, which is analogous to SQL, but Salesforce Object Query language. When I double-click on the Salesforce.com schema, a new tab opens up in my IDE, and on the right-hand side, I have all of my objects. So these are the standard objects, and this __C shows me my expense report custom object. So this is all very dynamic. It's reading it in real time, doing a describe of your data model. And it can expose down, and by using checkboxes, I can build a SOCL statement in the upper left-hand side, hit Run Me, executes a query through our API, and generates the data set and result. And I can see my sales demo for Phoenix is in draft status with the total. I can see the data in my IDE. Another powerful feature of our SOCL language is the ability to use relationships. It's similar to joins, but the syntax is slightly different. But again, it's leveraging that relationship, that master detail we defined between reports and line items. So I want to go to my child relationships, and in one query, I want to get both the parent and child. So I expose down here. I want to get the line item name. So I have an inner select statement to get the related line items. And when I hit Run Me, I still have my parent object. But if I double-click on that, you can see that in a single SOCL query, I can get my related items as well. So you don't have to do two queries to get the related data and then tie it together yourself. Our SOCL language supports that. Our Apex programming language, which we're not going to go into too much detail, also allows you to build PL/SQL-like database triggers. So as a expense report is created, you can also write some code to really add on additional functionality to extend our application and platform. So the IDE really gives developers a great environment to develop their data model and build their entire Force.com force.com application in addition to all the declarative features we showed through the user interface.
Awesome. I'm a techie and I quite enjoy using the IDE for a lot of my work. The IDE also has things like code completion for Apex when you're programming business logic. As you saw earlier in the demo, you can also use the online environment to do a lot of work. I mean, Andrew built a lot of this application declaratively by point and click. But force.com also has a standard MVC model, a model view controller paradigm, with which you can use to build your own web applications around the database. It's something that you can use to code your own interfaces, for example, and interactions with the data. And we call the user interface layer Visual Force, and it's a component-based markup language. And Andrew's going to show us a little bit about that right now.
Great. Thanks, John. So back in my browser, I wanted to just build a simple Visual Force page to show how you can really define your own UI and not use that standard page layout I showed earlier. This still uses a standard Salesforce styling or CSS, but it shows you how you can represent and display the data a little bit differently. So I built a page that lists out my expense reports, but when I click on that hyperlink, there's some AJAX controls that automatically queries and displays those related line items. And I can toggle between the two, and you notice the page doesn't refresh. You get that AJAX feel. You can also hit View to go create or to look at the details, similar to the page we showed earlier, or New. Very simplistic view, but just a way to show you that behind this page is this Visual Force markup language that automatically is tied into your data model and queries the data in real time, and you can display it through AJAX and paint your page as you like. But to really show you how far you could take your force.com application is I want to show you a company, Game Craze, built this Visual Force page on top of their force.com data model to power a page that is entirely custom. It gets rid of our styling. It is hosted and powered by force.com and their data model. So underneath here, things like the games are records in an object, but the UI is entirely custom, just to show you how far you can really take it and build on our platform. So with that, I'm going to transition back over to the remaining portion of the presentation.
Thanks, Andrew. Wow. So the presentation's almost over. I can't believe that. And I wanted to bring up the slide again. We saw it earlier. And by now, we've seen a bit about the database. You've seen how the database actually provides a lot more than just defining a data model. It gives you this bunch of great UI features and a lot more. You also saw some of the services like authentication and searching. And we saw a little bit about the Visual Force and Apex, which gives you that pixel-level UI control in a traditional model view controller kind of stack. And the force.com stack is actually quite highly integrated. So, for example, if you're going to interact with the database in the controller layer with Apex programming language, it's dead simple. You don't need an extra layer for OR mapping, for example. We also saw some reporting and validation and so on. And there's more too. I mentioned the web services earlier and the triggers. So some of this requires coding, obviously, and some of it doesn't. But at the end of the day, I hope we've convinced you that what it does give you is ease of development and productivity. So with that, back to Andrew.
We've talked a lot today about what the force.com database is and what it can do. But let's take a minute to take a step back and realize what the force.com database handles for us implicitly, and now as the administrator or developer, you no longer have to worry about. I know for me, when I started working with force.com database, I was instantly happy to know I didn't have to worry about ensuring that JDBC or ODBC connections were not only set up, but that the required third-party libraries were working together. The force.com infrastructure also has a built-in query optimizer to assist with indexing the data, and it internally handles all the caching, sizing, cursors, and optimization tuning. Those are major headaches with traditional databases that are handled by the force.com infrastructure, and let us as a developer focus on the data model and building out your application.
Cool. So what are the next steps? All of you have a Developer Edition account right now. And what I suggest you do is actually log on. And when you do that, you'll see this great front page. And that front page gives you access to a set of tutorials. And those tutorials will actually walk you through a number of the concepts that we spoke about today and go into a bit more depth. For example, they go into Visualforce as well. You've also downloaded the Force.com Developer Guide. There's a lot of great documentation in the Documentation tab. And we also have in the Technical Library a database section. And there's a nice article, Introduction to the Force.com Database, which also runs you through many of the items that we spoke about today. And before we leave you and go to the Q&A, I just wanted to mention that we do have an upcoming Tech Talk. It's the Force.com Sites Preview Tech Talk on June the 22nd. And you can register for that on the homepage right now. There's a banner which points to that. And we also have a number of archived Tech Talks. For example, we have one on Apex Code, which is the programming language. We have an advanced one on Visualforce for building those components that you saw, and one on Summer 9, which is the next release of the Force.com platform. So thank you very much, and now we'll head over to Q&A.
Great. Just give me one moment to pull up some of the questions.
So I have a question here, somebody asking how to get to the workbook. You can actually just go to the URL directly if you like. It's developer.force.com/workbook. That's developer.force.com/workbook.
All right. Here's a question. Why do the last three characters in the ID change when data is pulled using the APIs? This is to provide case insensitivity when replicating data to a traditional on-premise database. Some databases don't support case sensitivity, or if they do, they may not have been configured that way.
That actually brings up another question, which was somebody said their record IDs were 18 characters. And I think it's somewhat related. There are some applications that don't recognize a case-sensitive form from a non-case-sensitive form. And so there is an 18-digit case-safe version of the ID that's returned by API calls, for example.
Here's a question. If I don't use Eclipse, can I still see my organization's metadata in a browser-like tool? Absolutely. There's a couple of tools available on developer.force.com that our community has submitted, tools like Workbench, Apex Explorer. There's even a Mac version called Sockle X that you can install to your Mac platform that allows you to do the very similar Schema Explorer query analysis and see your metadata that way.
There's a question about during the creation of the object tab, you have the chance to say what profiles can see the tab, but there's no step to say only these profiles can see or have CRUD access to the object. And so the question is, did I miss the CRUD step, or is it just not there? What you can do is actually go to that setup menu that Andrew was using and go to the administration setup, manage users and profiles, and there you can set up the CRUD on the object for the profile. So that's set up administration and then manage users.
All right, looking through some of these other questions. During the creation of the object in the tab, you have a chance to say what profiles can see the tab, but there's no step to say only these profiles can see or have CRUD on the object. Did I miss the CRUD step? You can, if you go up as an administrator, if you log in and go to Setup, Administration, Setup, Manage Users, you'll see all of your profiles. And within each profile, you can define the CRUD for each object permission, which is enforced both at the data layer as well as the user interface. So even after you're done creating the object in the tab, it's within the profile and managing the profile that you can set specific CRUD permissions.
There's a question here about why do we choose the option Allow Reports? Is there something going on in the background? And there is a little bit going on in the background, and really it's about informing the reporting and analytics engine that it must now be aware of this object and changes in the object. So if you don't have that option selected to allow reports, then you won't be able to use that object to generate reports.
I see another question about how do you create a one-to-one relationship between objects. Just thinking out loud here, the way I would do it is still to use the master detail or lookup relationships to define and relate the two, but you could put an Apex trigger behind one of the custom objects to enforce that only one and at most one record can be related to it. So you could use some Apex code to really enforce once one record's created, not a second or many records could be created. And with that, I believe looks like we've gone through all of the questions on the list here. So I'd like to thank everyone for their time today. I hope you found it valuable, and look forward to talking with you in future Tech Talks. Thank you very much.